graph the given function, state the domain and range, list the y-intercepts and any x-intercepts if they exist. My function is f of x equals the square root of x plus 1 minus 3. For my domain, I'm interested in which x values can go into my function. One thing I notice is that I'm going to be restricted because I cannot take the square root of a negative number. So when I state my domain, I'm interested in which x values will enable me to make sure that I have a positive right here. In other words, x plus 1 has to be greater than or equal to 0. If I subtract 1 from both sides, I get x is greater than or equal to negative 1. So my domain then will be from negative 1, and it will include negative 1, all the way to infinity. So a bracket for the negative 1 and a parentheses for my infinity. For my range, if negative 1 is the critical value, and I'm looking at my function, if I put negative 1 into here, I have negative 1 plus 1, so that's 0, and I start with negative 3. So for this, I'm looking at y, then, it has to be greater than or equal to negative 3. So my my range will be from negative 3 to infinity. In terms of my x-intercepts, I want to let my y usually, but in this case, my f of x equals 0. So 0 equals the square root of x plus 1 minus 3. I can add a 3 to both sides so that I have 3 equals the square root of x plus 1. And then to eliminate the square root, I can square both sides of my equation so that I have 9 equals x plus 1. Subtracting 1 from both sides then, I get 8 equals x. Since this is an x-intercept, I'll have 8, 0 as my coordinate. For my y-intercept, let the x equal 0. Or in other words, find f of 0. So in this case, it'll be 0, the square root of 0 plus 1 minus 3. 0 plus 1 would be the square root of 1 minus 3. Square root of 1 is 1 minus 3. Or simply negative 2. So my y-intercept will be at 0, negative 2. When I go to graph this, I want to create a table which I used negative 1, 0, 3, and 8 because I was thinking about which values would be perfect squares. Thinking about 0, 1, 4, and 9, the values that would make my radicand 0, 1, 4, and 9 would be negative 1, 0, 3, and 8. That's why I chose those. Putting those values in, negative 1 plus 1 minus 3 is going to equal negative 3. So I have the coordinate negative 1, negative 3. If I put 0 in, I get the square root of 0 plus 1 minus 3, which is going to be negative 2. So I have the point 0, negative 2. If I put 3 into my function, I get 3 plus 1, the square root of 3 plus 1 minus 3, and that's going to equal negative 1. So I have the coordinate 3, negative 1. And finally 8, the square root of 8 plus 1 minus 3, that's going to be 0. So I have the coordinate 8, 0. Plotting these points on my graph, negative 1, negative 3, 0, negative 2, 3, negative 1, and 8, 0, I get a sketch of my graph.